Alright, so let's have a look at how the MetaHuman system is set up. At the beginning, all those folders and files might seem a bit confusing, but we don't actually need most of the stuff here. Nonetheless, let's quickly browse through the folder structure and then have a look at the character in more detail. I will cover the following topics in this video: the MetaHuman skeleton, or rather skeletons, because we actually have two of them, the blueprint, and the materials and textures of the MetaHuman. This is actually quite important to understand, since this will drive some of the decisions that we make in our customization workflow later on. When we import a MetaHuman to Unreal, we get a folder with the name of our character, in my case the hero folder, and another folder called common. This common folder contains all the assets that are actually shared by all MetaHuman characters, independent of the specific model. Like, for example, the MetaHuman base skeleton, physics assets, most of the blueprints, materials and animations. The character folder is the place where all assets that are unique to this character are stored, like the character blueprint, the head and body meshes and textures, hair binding assets, etc. Since it is sometimes difficult to find a specific asset, for example the skeleton, in all these folders, I usually go to the blueprint components and then open assets from there, or use the locate asset function to jump to the correct file. Okay, now let's have a look at the skeleton. Select the body component in the blueprint and then double-click on the skeletal mesh. In the editor you can show all the bones of the body skeleton by going to Character, Bones and then choosing All Hierarchy. You can click on the bones to select them in the viewport, but a better or more precise way is to select the bones in the skeleton tree. Compared to a simple character rig, the MetaHuman skeleton is a bit more complex, with lots of tiny little bones with names like twist, bulge, corrective and so on. All these additional bones are used to approximate muscle movement in the body and face. Let me demonstrate. You see how the chest muscles deform, or how the biceps and triceps are actually bulging when the arm is bent? Even for the fingers, there are small bones that control the deformation. Let's have a look at the face rig now. Open the skeletal mesh editor and show all bones. You see, the face rig is even more complex. It shares a couple of bones with the body skeleton, like the spine and neck bones, but all the other hundreds of bones are responsible for driving the facial movement. If you go to the animation asset, you can actually see how all the bones are moving when the animation is played. So our finding number one is the character has not one but two skeletons. The body and face rigs are separated. This is of course not without purpose. That's the beauty of it, because you can assign an animation to the body and then drop a secondary animation layer for the head and face on top of it. You can use either a pre-recorded animation for the face using Faceware or other software, or you can use the ARKit Live Link for real-time facial motion capture. Cool, interesting. But how does it work that the head actually follows the body movements, although it runs on a different rig? If you open the Face Anim BP, which is the blueprint for the head and face animation, and then open up the Anim graph, you will find a small node connection called Copy Pose from Mesh, assigned to the body pose. This copied pose then feeds into a layered blend node where the two rigs are joined together. Let's see what happens if we disconnect the copy pose node in the blueprint. The head then stops following the animation assigned to the body skeleton. If we reconnect it, the head gets back into place. Another thing that we should look into is the skinning of the character. As with all animated character models, the deformation of the mesh is driven by the vertex weights assigned to each bone. The process of weight painting is also called skinning. You can inspect the vertex weights directly in the engine if you go to the mesh editor, click on Character, Mesh, and then activate Selected Bone Weight. When you select a bone in the skeleton tree, you can see which part of the character mesh would be affected by the bone's rotation. Let me show you the skinning in Blender. For this, I export the body and the face meshes as FBX files and then import them in Blender. If you select the skeleton and then shift select the mesh, you can go into weight paint mode and see how bone rotation affects the body movement. Now, why are we looking at this? Well, we have a small complication here. The separation of the body and head meshes happens somewhere below the clavicle. That means that if we create clothes for a metahuman character, the skinning of the body does not have any information on the upper chest and neck part. To make matters worse, the skinning of the head is not straightforward either. There are no vertex weights assigned to the neck bones. Between spine 04 and the head bone, all the skinning is regulated by a multitude of tiny bones of the face rig. This will be important for clothes modeling and skinning. What is usually done is we copy the weights from the body to the clothes, so the clothes deform in approximately the same way as the body. But since there is no information on vertex weights for the upper chest part, there is nothing to copy from. We will see later how we can deal with this issue. Okay, we have now covered most of the questions concerning the skeleton setup of the metahuman characters. So what else do those characters offer in terms of functionality? Well, for one, both the body and face come with a control rig. If you create a sequence and drop the blueprint into the sequence, it automatically detects and displays the control rigs. This is very useful for keyframe animation or for polishing your motion capture animation. For a faster workflow, there is also a utility widget called the MetaHuman Control Picker, which you can find in the Utilities folder. Here you can quickly select one of the controls and switch between IK and FK, which stands for inverse kinematics or forward kinematics. The last functionality we want to look at are the face blend shapes. The face comes with over 200 different blend shapes or morph targets for facial animation. This is how these characters can achieve an incredible quality of emotional expression. Alright, let's wrap it up. What have we learned? First, when we work on the character, we want all this goodness to remain intact. If we export the head, for example, modify it, say with the sculpting tools in Blender, and then bring the FBX back into the engine, it will lose all the blend shapes, control rig, etc. Now I know all of this and much more is possible in Maya since the metahuman characters come with the Maya source files. But for Blender users this presents a real challenge. And second, clothes need to be rigged to the body skeleton since the head follows along with the body animation. And we need to solve the problem of the upper chest. Also, something to keep in mind, in case you are using the head rotation with the AR kit, those head movements will not be transferred onto the clothes. So the use case will determine what we can do in terms of clothes items. The decisions we make concerning the animation workflow for our character will influence the options we have when it comes to creating clothes, hair, and other props. Next we will have a look at the blueprint of the metahuman character. So the main asset really, where everything comes together, is the character blueprint that is located in the main character folder, in my case the hero folder. By the way, there are different ways to open the blueprint. You can either double click on the blueprint asset here in the content browser. You can click on Edit Blueprint in the outliner, or you can click on this blue button and select Open Blueprint Editor with your character selected. With the Blueprint Editor open, let's go and have a look at the character in the viewport. On the left you see all the components that come with the imported character. You see that the body and face skeletal meshes are here. Attached to the face are all the hair groom components. Each hair groom component is always accompanied by a so-called binding asset. This binding asset is responsible for the movement of the hair with the face geometry itself, so that the hair is not just static, but actually moves along with the facial animations. Let's see how it looks. In addition, the blueprint already contains 3 slots for clothing: torso, legs and feet for upper body clothes, pants and shoes. Since we disabled the clothes when we created this character in the MetaHuman creator, the slots are empty except for the flip-flops, which I already disabled as well. To disable the flip-flops, just click on the feet component and under skeletal mesh select Clear. You are of course by no means obliged to use all these slots for clothes, as you can of course also assign a full body outfit to the torso alone, but this gives you some flexibility in setting up your character. We will see how this works in a later chapter, when we come to creating clothes for our hero. At the bottom of the list there is another component called LOD Sync. This regulates the level of detail for all the components that are in this blueprint. In the Details panel, you can force a specific LOD. For example, set all components to LOD 0, if you don't want your hair to disappear at a certain distance. There is already a whole program set up for the character in the main blueprint and also in the Face Anim BP, among other things. But we will look into all that in another chapter of this course. Basically, what we need to know for the purpose of customizing our character is: first, when we design clothes, it is good to consider that the torso, legs and feet can be different. We can also assign a full body outfit, as I said, including shoes, to the torso alone, so we don't need to always split clothes into those 3 parts. But this modular setup allows us to be more flexible. And second, in principle we have little limitations when it comes to adding stuff to our character. We can create new hair assets, clothes, physics assets and even attach static meshes to it like goggles, heads and other things. Almost anything is possible in the blueprint. Alright, next let's have a look at the materials and textures and see what we can work with and whether there are any limitations when it comes to texturing the character. Let's look at the face first. The main material instance for the face is the very first one on the material list, called Head Synthesized Baked. It comes with an extensive set of parameters to adjust the look of the face. The master material for the face can be found here. Let's open it up. The face shader is quite complex, but we don't need to understand every single node in the material editor. What is important to know is which textures we can customize, so the character still works as intended. For us, the 2 most important texture sets are the base color and normal map textures. To achieve more realism, the MetaHumans use several sets of texture maps for the color and normals. There are 4 base color maps that are used to show little changes in how blood flow is affected by facial movements. When you squint your eyes or open the mouth, certain skin areas become more red or pale depending on the stretching or condensing of the skin. This is what these 3 additional base color maps are for. In the normal maps, there are 3 wrinkle maps for the face, which simulate the skin deformation in the facial animations. As a test, let's remove the first wrinkle map, which is mainly responsible for the forehead. You see, the result is quite considerable. Quite interesting to see is that the face textures have different resolutions. The metahumans are not brute forcing their way into visual quality. To achieve a high level of details, the normal maps come at 8K. Remember, by the way, it depends which download settings you used in Quixel Bridge. But the base color map is only 2K, since most of the details are controlled by the normal map. So the guys who made this already thought about optimization, even for LOD0. If we now look at the body material, this one is much simpler. It only has one base color map and one normal map. The texture setup is similar. We have a 4K texture for the base color and an 8K texture for the normal map. The last thing I would like to show you is how the UVs for the body and face are laid out. The UVs for the face first look like a total mess. This is because the UV maps for the head mesh, the eyes, eyelashes, tongue and teeth are all sharing the same UV space. The only UV that is interesting to us, however, is the head synthesized material. The body UVs are located on the second UV tile. This is important to know for our texturing workflow. So, wrapping up, when it comes to customizing textures for our character, for example changes in skin color, tattoos or whatever else we would like to adjust, we need to consider the following. First, the facial deformations. This is concerning color and wrinkle maps. How important are those, and do we want to keep them? If we don't, then we just replace all those additional maps with the main map. If we would like to keep those, we need to work on all those maps separately. And second, if we want to texture the body, and especially if we want to add texture elements like chest tattoos that cross over from the body mesh to the chest part of the head mesh, we need to use a UDIM texturing workflow in Substance Painter or whichever other software we use for texturing. Well, this concludes our analysis of the MetaHuman character setup. You can find the main points that we have discussed here also in the course book, by the way, so you don't have to rewatch the videos every time you would like to go back to this character inspection. And equipped with this knowledge, I think we are now ready to begin customizing our hero. In the next chapter, we will dive into a workflow for creating and baking morph targets for our MetaHuman. You will learn how to deform the mesh of your character without breaking anything. See you there!